This is the first of 4 videos that I'm going to do on the effect on the translation or transformations of the sine and cosine graph. This first one I'm going to look at is the vertical dilation, and that's this a value. What happens when you multiply sine and cosine by a number a? This a, the a value, is going to have a special name called amplitude, and I'll explain more about that later on. But the amplitude is exactly what a is equal to. It's the absolute value of a is equal to the amplitude of the graph. And later on we'll look at what these other letters do, but for this one I'm just going to focus on what happens with a, or what does a do to the graph. So I have a sine function, and I've just used decimal numbers for all of these, because sine of pi over 6 is exactly 0.5. Sine of pi over 4 is about a square root of 2 over 2. Square root of 2 over 2 is about 0.707. So 0.7 is okay for plotting points on a graph. And square root of 3 over 2 is 0.866. So that's close to that. And square root of 2 is 1. Sine of pi over 2 is 1. So those are just decimal numbers to help me figure the rest of this out. So if I multiply the sine function by a negative 2, I'd like to know what happens. So as sine of 0 is 0, multiply 2 times 0 is 0 again. Okay? Sine of pi over 6 is 0.5, so negative 2 times the sine of 0.5 is negative 1, and etc. So I've just multiplied each of these points by the negative 2, and it gives me this bottom row of points. On the graph, that has the effect of taking each of these points, if I multiply by a negative 2, that reflects it down, so I get the sine graph that goes down first and then up. And all of these points are twice as far. Here, this point is twice as far away from the horizontal axis as the original point. This distance from here to here is called the amplitude. That distance between the line that cuts across the graph and its peak is called the amplitude. So the amplitude of this graph, amplitude is equal to the absolute value of a. Absolute value of a is, or a value for this graph is negative 2. So the absolute value of negative 2 is 2. So our amplitude for this graph is 2. And again, the negative 2 has the effect of reflecting the graph down and stretching it vertically. For the cosine, again, I've used decimal numbers for these just to help me graph. For the cosine, I'm going to multiply by 3. So 3 times 1 is 3. 0.86 times 3 is about 2.6, and etc. I've just multiplied each of these numbers by 3. So I've taken the cosine of the angle and multiplied that value. Cosine of pi over 6 is 0.86. Multiply that value times 3, it gives me a new value for the same angle. And again, you can see this has the effect of stretching the graph vertically. All of these points are 3 times as high as the original point. So here's the original graph. It's been stretched vertically this way and also this way. These points are 3 times as far down here. And again, the amplitude from the highest point to the line that goes across the middle of the graph is the amplitude. Amplitude is equal to the absolute value of a. In our case, a is equal to 3. So the absolute value of 3 is 3. So the amplitude of this graph is 3 units, whatever the units are. So again, the multiplying has the effect of stretching it vertically. If it's a negative, it reflects it first and then stretches it. Okay, so that's a brief introduction to what happens when you translate or dilate a graph, a sine and cosine graph.